working. Perfect. Welcome to the Sweet Science of Fighting podcast. Today, we have James Steele. Welcome, James.
Thanks for having me.
All right, thank you for coming on. I came across you from the Iron Culture podcast. Was actually where I first heard of your stuff, and then obviously being on your research gate, you have like 1 billion papers published. So it'll be interesting to kind of dive into some of your research and things going on there. But for people who aren't familiar with you, do you want to give a little brief background and kind of what you're doing now?
Yeah, sure, absolutely. So I guess long story is short story rather is I've been an academic for probably most of my career. So I started off with undergrad in sports science here in the UK, and went straight into a PhD. And as you said, I've got a lot of papers, and that's partly because I've had a lot of eclectic research interests over the years. So whilst most of my research has been around kind of resistance training and strength and conditioning, my PhD was actually more in kind of clinical exercise. So I was working in chronic low back pain and looking at resistance exercise interventions in back pain. Worked a lot in kind of more, the typical kind of strength and conditioning world research-wise. Also worked in more public health fields as well. So I spent a number of years working for a company here in the UK called UK Active, which are a not-for-profit who kind of do a lot of public health-related work. And then probably in more recent years as well, and anyone who's listened to episodes of Iron Culture with myself on, I've been very heavily involved in kind of the open science movement and trying to sort of improve rigor of the research that's done in our fields of sport and exercise science. And then, up until last year, like I say, I was an academic based at Solent University and associate professor in sport and exercise science. But unfortunately, with the way the sector is at the moment, cuts had to be made. And I would say I was a victim of one of those cuts, but as we were just talking about before we jumped online, it was definitely a blessing in disguise. And now I am working out in industry. I do a lot of consulting on research for industry partners. I'm also head of research for a company called Kiza, based in Australia, who are a company that have a network of clinics that offer physiotherapy, exercise physiology, and evidence-based strength training. And also doing a number of other bits on the side as well, doing a bit of work with Greg Knuckles and the team at Stronger by Science and Macro Factor as well. So, enjoying it now. Been a man of leisure. Getting involved in all sorts of different research projects and getting to kind of flex my research chops.
That's cool. Well, this is going to go a way I didn't plan because I like to just shoot off the hip and all of this. You mentioned obviously you did your PhD a lot on back pain and exercise. There's obviously, I don't know if you're able to speak to this at all, but obviously the prevailing mainstream fitness take on back pain is you have a weak core and your glutes don't work. Do you want to maybe go into a little bit of that for the listeners just to maybe clarify maybe what's going on there, and then maybe what the potential causes of, the most common kind of lower back pain might be?
Yeah, sure. I should preface it by saying it's been some years since I've kind of been focused on that area of research, but I could certainly talk to what I was working on during my PhD and for a number of years afterwards, which was, we did very much focus on looking at low back pain as being this kind of multifactorial kind of condition. It is something that is highly prevalent and has a number of possible causal factors that are linked to it. So, and now one of the things that I focused on during my PhD was specifically looking at muscular deconditioning. But unlike a lot of research in the area of low back pain that looks at kind of weakness and deconditioning, focuses on either, broadly speaking, kind of deconditioning, which also gets kind of like lumped into with low activity levels as well, and they kind of get used synonymously. Or, as you say, looks at things like glute weakness or, very, very kind of specific kind of weaknesses of certain musculature. One of the things that we looked at, though, was more the lumbar extensor musculature as a whole. And so some of the initial work I did was some large systematic reviews, kind of reappraising the question of, like, is deconditioning a possible causal factor in low back pain? Well, it might be, but it depends on what you mean by deconditioning when you say that. So broadly speaking, there's probably not great evidence for it. But we looked across a kind of range of different areas, including studies that have differentiated between testing trunk extension weakness, so weakness or tasks that would involve both hip and lumbar extension. So, typical deadlift or kind of trunk-based activities, versus studies where they had been able to kind of isolate and remove hip extension to be able to test lumbar extension in isolation. We were very fortunate at the lab where I did my PhD, where we had a machine that was specifically designed to essentially kind of completely restrain the pelvis so it can't rotate. And so the only motion you can perform is kind of like lumbar extension flexion. And so testing that in isolation. And interestingly, actually now working with Kieser, part of the reason they reached out to me to offer me a job is because all of their clinics have this machine in each of their locations. So the physiotherapists use it a lot for testing and also for training. But yeah, when you differentiate between studies that have looked at lumbar extension versus trunk extension, there is consistently deconditioning of the lumbar extensors in people with low back pain. There's some evidence prospectively that it is predictive of low back pain occurrence. When you look at studies that have looked at more imaging methods, there is consistently reduced cross-sectional area, greater fatty infiltration of the lumbar multifidus, the erector spinae. And one of the problems, though, with this is that a lot of these studies also are confounded by the fact that so many people with back pain nowadays often end up having surgery as well. And so one of the first studies that we did with some of my students was to actually conduct a larger cross-sectional comparison of people with and without back pain, but controlling for whether they had previous surgery. So to see because surgery obviously has a big impact on the lumbar extensor musculature as well. And so we see that when you control for surgery, there's still significant weakness in those with low back pain. And then, we've done a lot of intervention work around that as well, using specifically isolated lumbar extension resistance exercise to kind of re-strengthen the low back. We've reported some evidence when we've kind of synthesized across our RCTs to show that, at least from an associational perspective, those who seem to have greater gains in lumbar extension strength seem to also get better clinical outcomes like reductions in pain and disability, whereas you don't tend to see that with other kind of modalities. So some of your more typical kind of transverse abdominis training programs have shown that there's no real association between changes in TVA function and clinical outcomes. So it was interesting to see that with the lumbar extensor work. And then also have done some work as well looking into kind of the evolutionary origins of why do humans just in general have pretty weak lower backs relative to their glutes and hamstrings and so on. So by no means the only possible causal factor, but I think there's certainly some plausibility to lumbar extensor weakness is unfortunately just a thing that, relatively speaking, humans have. It's a difficult thing to kind of train, and you're more prone to injury if you're weak, and so there is some element of a causal pathway there, but certainly by no means the only thing that can lead to back pain.
Well, it reminds me of when you mentioned that the transverse abdominis stuff. I don't know if you've ever read or remember the paper, the myth of core stability, I think it was called.
Oh gosh, yeah, I remember reading that during my undergrad.
Yeah, and talked about how about transverse abdominis, maximum voluntary contraction of it when you're standing is only 1% or something like that. So do we need to strengthen it more? And it was actually quite an interesting paper. What are your thoughts on that paper? Do you think that it had some relatively good, I guess, standing or evidence?
Yeah, I mean, it's been a long time. It's probably been 10 years since I read it. But from what I recall of it, it was interesting. I remember reading it, like I say, I think I was an undergrad. I think it was, it's A.L. Lederman, if I remember rightly. I'm sure it was a 2009 paper. I do remember reading that paper and it being quite sort of influential of thinking. And it was partly what kind of led me down the route of wanting to look at the lumbar extensors specifically, because of their the role that they play in controlling gait and so on, and they are kind of potentially a weak link, so to speak. I feel like I'm using a lot of the cliche terminology, but it's hard to not fall into it.
I'm waiting for glute amnesia, and I'm waiting for inactive
I've got very
isolating transverse abdominis and
got
stuff.
very
You know?
little comment on that. I mean, the biggest risk factor for low back pain really is low back pain itself, and this is one of the things that I've kind of we sort of pointed out in our reappraisal of this kind of deconditioning hypothesis is a 2003 paper. I think it was Crossman and colleagues made an astute observation, which is that actually I'm gonna have to find it because that's gonna be one of those annoying quotes which I'm gonna butcher if I don't remember it off the top of my head. So there will be one sec while I quickly get up the paper, because that will bug me if I don't.
Yeah, if anyone's interested in that myth of core stability paper too, that's the title. The myth of core stability is by, as you mentioned, E.L. Lederman.
That's it.
In 2010. Yeah, that fully like opened my eyes to, I guess, all the different arguments on quote unquote core stability and like pain and function, etc.
Yeah,
it was quite a good paper.
So the typical kind of like disuse or deconditioning syndrome as it's presented is that like it's pain results in avoidance behavior that results in then disuse and deconditioning, and it's not that deconditioning or leads to pain. It's that pain leads to deconditioning because it results in avoidance behaviors, but the pain is the biggest predictor of subsequent back pain in the first place, and it's one of these kind of like logical necessities that there's got to have been something that caused the pain in the first place, and typically that is some sort of injury or noxious stimuli in the very first instance when it comes like all chronic back pain starts as acute back pain because that's just how time works, well at least for us as macroscopic individuals living in a roughly 3D plane, but yeah, the quote I was thinking of was from Crossman and colleagues, and it was one of the things that kind of led us down this kind of I went down a rabbit hole, much to my PhD supervisor's dismay at the time, of digging into the paleoanthropological literature and trying to figure out, coming across this quote from Crossman and colleagues where they said, in none of these studies were any mechanisms offered up to explain how normal paraspinal muscles could dysfunction to predispose to low back pain, which was kind of what led me down the route of looking at it from an evolutionary perspective to say, well, we unfortunately have a possible hypothesis is that we have the evolutionary burden of the fact that we have larger, more powerful hip extensors, glutes, hamstrings, and as a result of our typical kind of like evolutionary environment, we just didn't necessarily need to have strong lumbar extensors at the time, and there's a kind of like trade-off that's occurred as a result of our sort of evolution from more sort of arboreal quadrupeds who typically or through down to kind of more common ancestors that had those larger glutes and hamstrings, and we kind of bear the burden of having this kind of like long flexible lumbar spine with relatively weak lumbar extensors. And another interesting observation as well is because one of the things that I again, early on in my career, I got a bit interested in the whole kind of like paleo movement, and partly because I kind of got interested a little bit in the diet and a little bit in the kind of exercise claims and these kind of claims of like paleo fitness and that sort of thing, and at the time as well, there were a lot of kind of I was seeing a lot of people claiming that more kind of quote unquote evolutionary kind of appropriate movement patterns would.
It's still going on right now.
It amazes me
because and it's bigger than ever.
Really?
Functional patterns have been pushing this all over the place. There's a bunch of them.
I'm so out of this kind of like area now that I'm kind of glad, because I get frustrated with it. So because you would see claims of like more traditional kind of hunter gatherers, or more sort of like rural populations and kind of herding populations and things like that. Basically, anything. It's the whole sort of like disease of civilization thing. Like low back pain is a disease of civilization. It's not a kind of evolutionary disease. But when I was like, well, there's got to be some studies that have looked at this. So I went and found all the studies I could that reported low back pain prevalence in more kind of traditional populations, rural Indonesians and Malaysians and Thai rice farmers and New Guinea Highlanders and Maasai and all of them. And there's not a lot. There's maybe sort of something like 10 or 12 of these studies that I found at the time. This is about 10 years ago now. But in pretty much all cases, you find prevalence of back pain is pretty much the same as what you see in common kind of quote unquote modern populations. And in the studies where you don't see high rates of prevalence, it's normally because they don't want to be telling some white doctor who's come to them that their back hurts, because that seems to be, a sign of weakness and so on. And there's actually some interesting qualitative work that's been done in kind of remote populations to try and find out, like, why don't they report when they have pains and diseases and so on. So it just seems to be that it's one of these unfortunate things that, like, people are prone to get back pain just because we're human, unfortunately. And it's probably because, it can be because of a bit of weakness and injury, and that can lead to chronicity and so on. But it's an interesting topic, and it's one of these topics where I've not been involved in it heavily now for probably just shy of sort of the last decade or so. But it was certainly where what brought me into the kind of research world was through my PhD working on that topic.
Oh, I love it. That was awesome to go through the back pain stuff. But I want to actually, the title of this podcast was about periodization, and I want to jump into that as well, because we actually have a few questions in the live chat, but I'll get to those once we go into it. So you wrote I think it was a paper or a chapter recently around the myth of periodization. I had John Kiley on the podcast maybe a couple of years ago now, talking about I guess the same topic from his. If you're anything like me, you're short on time. Kids, family, work, training, and having to cook meals on top of that, it's just not going to happen. So I'm happy to announce Trifecta Nutrition are sponsoring the podcast. You get epic meals like these ones: turkey taco bowl, Texas barbecue protein plate. These are a couple of my favorites. But it means you don't have to prepare all your own meals, and it makes getting and good nutrition relatively easy. I've tried other meal delivery companies. Most of them are too high fat, not enough carbohydrates, or if you're getting kits where you have to cook it yourself, the portions for two is actually for one, especially if you are like me and you're training often. So if you want to take something off your plate and have meals like this delivered to your door, go down the description. There's a link there where you can order Trifecta meals. This is the performance line, which are higher protein and higher carbohydrate. And you can use code LIFTBIG40. You'll get 40% off your first order. Research. So I'd love you to go into, just, I guess, wherever you want to start in terms of the myth of periodization, your thoughts, your take on it and everything.
I'll say, actually, it's actually a book chapter. I actually got sent a copy of the book, so it's actually a book chapter in this book from Jenny and Amy.
Myths of Sport Performance.
Myths of Sports Performance, if anyone's interested. So a friend of mine wrote the introductory chapter to this. He's a sociologist and wrote this interesting chapter on kind of like what are myths from a sort of sociological perspective. And he said I'd be a good person to contribute something, and I thought, well, what would be a good topic to talk about from this? And I'll give you a little bit of kind of an insight into this paper, because my friend Chris, who's Chris Matthews, as I said, he's a sociologist. He often uses this phrase of doing philosophy by stealth, because sports students typically, and he works in sport, don't want to be taught things like philosophy of science and things like that. No one goes and does a sports degree thinking that that's what they're going to get. And I found that out subsequently as well, because I taught for the last sort of part of my academic career, I mostly taught research methods, and I taught philosophy of science and statistics to sports students. And so I needed to come up with good examples that were kind of salient for them, to get them to understand and learn these concepts about, like, what is research, what is science, like how do we produce the knowledge that we have, and how do we go about kind of testing that knowledge. And so when I was invited to produce this chapter, in my head I thought, I'm going to secretly write a chapter on the philosophy of science, but everyone is going to think it's a chapter about periodization. And so that's kind of the exegesis for it. But so myself, my colleague James Fisher, and then also Jeremy Lenicky and Sam Buckner from University of Mississippi and University of South Florida, all contributed to this chapter. And for those of you who haven't read it, it is available as a preprint. So there's an open access version of it online. And if you just search The Myth of Periodization, it will pop up. And it's, as I say, it's got a nice provocative title to it. But the paper's kind of split into two sections because of that. So Jeremy, James Fisher, and Sam have written a lot about, and I have in collaboration with them as well. But they've written and focused a lot on the kind of methods of particular studies that have been purported to either test concepts in periodization or anything like that, and also written a lot about like what do we actually mean when we talk about periodization, because the terminology in the literature is very loose and difficult to kind of like get a grasp on. Like almost anything gets called periodization nowadays. And so the papers or the chapters kind of split into these two kind of like parts, which one is a brief review of the kind of current evidence and the empirical data that we have, or the lack thereof, as it subsequently is. And then the second half is more talking about some of the kind of broader kind of philosophical aspects of why we call periodization a kind of myth in this sense. So yeah, that's kind of the background to the paper, and as I said, some of the critiques from Jeremy and Sam have typically been that kind of periodization gets pitched as this kind of long-term planning, this management of varying kind of demands on an athlete, and yet most of the studies that get used to support periodization are typically short-term studies. They don't really reflect the sorts of things that periodization is purported to address. Also, studies that have looked at strength adaptations, the outcomes from those are probably more parsimoniously explained by the concept of specificity of outcomes. In studies, I think John Kiley's spoken about this as well, is that if you test on a particular exercise and one group is kind of quote unquote periodized, but what that means is that closer to the test they train with heavier loads, and you're doing a max strength test, well, they've just had a chance to practice lifting heavier loads a bit closer to the test, and so are a little bit more attuned to be able to produce a greater performance. And so where we see these kinds of outcomes for strength, certainly, they're probably more simply explained by a more simple theory than alluding to kind of periodization as an explanation. And certainly then when we look at the kind of muscle growth outcomes, there's a lack of evidence suggesting that there's really any meaningful differences in terms of muscle hypertrophy between these different programs. And that the hypertrophy question is an interesting one as well, because as I've been working on other areas now, looking at other intervention comparisons and hypertrophy as outcomes, purely from a statistical perspective, none of the studies in our literature are anywhere near possibly large enough to be able to detect what could be reasonable differences in hypertrophy from these outcomes. To put it in perspective, the magnitude of hypertrophy as an outcome is very small from just resistance training compared to not resistance training. And so the comparisons between two interventions inherently has to be smaller. And the smaller and smaller the effects get, to detect them, you need bigger and bigger samples. And we've just finished up planning a study in trained persons looking at volume in resistance training. So we're going to be conducting a study that is going to be a large-scale randomized controlled trial. So we're looking to recruit 180 participants based on our planning, and we'll be comparing kind of quote-unquote the kind of evidence-based optimal higher volumes of 36 sets per week to a low-volume kind of 9 sets per week protocol. And based on our kind of predictions and simulations, like if we wanted to test for what we would expect the magnitude of difference to be between those interventions, we would need like well over 1,000 participants to be able to detect it. It's so small. And so instead we're testing for what's called statistical equivalence between the two So yeah, so like as I say, the empirical evidence is kind of lacking for hypertrophy, as we'd expect. Maybe there is a difference, but it's probably too small to care about. Well, I guess that depends on your perspective, but and certainly for strength, like it's probably better explained by that kind of principle of specificity. But yeah, so I don't know if you feel free to interrupt me at any point because I'll keep talking. I'll
gonna throw a
waffle.
question at you.
Yeah, go for it.
Around you mentioned that I think it was how periodization is defined, at least within the literature, is a little wishy-washy, if I'm paraphrasing. Do you want to maybe define, okay, then what is periodization, then what isn't? Because you mentioned one group could be periodized and one group couldn't be. But obviously, if you just think periodization as on a macro level, it's kind of just planning, right? Generally. So how do you go non-periodized versus periodized in a training program, if that makes sense?
Well, this is one of the problems, and there's been a shift in the literature to try to differentiate between what they call periodization, which again, it's always hard to pin down like a good definition. I'm not saying that there aren't definitions, but a good definition that meets the kind of necessary and sufficient conditions that you would need to be able to say, like, that clearly differentiates this as being that and that as being this. And so you see nowadays periodization and programming get thrown around. And I think in modern kind of terminology, the likes of people like Professor Stone and colleagues will refer to periodization as being this kind of broader planning, and maybe that involves kind of focusing elements of training on certain kinds of stimuli at certain points in time, or maybe ordering them in particular ways, because that will the theory is that should optimize outcomes, or managing it such that you're not providing too much stress at given periods of time, whereas like programming is kind of referred to as being the like the nuts and bolts of like how many sets, reps, and this, that, and the other do you do. Interestingly, though, and we point this out in the paper. If you go back far enough and you look at work from some of the early proponents, you see that actually the terms periodization and programming are used in the exact opposite way. If you go back, I'm gonna forget off the top of my head, but there's an early in one of Verkhoshansky's books where he talks about this debate and uses the terms in the exact opposite way. And so over time, like you can see where how this can be confusing. It's like, well, what are you talking about when you say periodization is better than non-periodization or whatever? But this is what also makes it really difficult to then, from a theory perspective, and this is where I get into the kind of the philosophy of science, is if you can't, a theory needs to be well specified to be able to make strong predictions. And this is where kind of like, the ideas of Karl Popper as a philosopher of science was always that one of the problems with kind of what we call using the inductive mode of inference, of saying like I observe things and then I draw inferences from them and try and draw generalizations. Like I did this and these things happened, therefore doing that probably causes these things. Is only ever leads to kind of this kind of probabilistic inference. It could be that you do that thing one day and it doesn't work. Whereas like Popper always said that what we do is not try to corroborate our theories and try to kind of like prove our theories. We try to falsify them. But in order to do that, we need to know what our theories tell us should happen, if indeed they were true. And to do that, they need to be clearly specified. Like we need to know that like, what we mean by periodization and what it implies, logically speaking, if we said like, well, if we manipulated training in this way, which what we call that periodization, then we should get these outcomes. And then if we could do that, we could derive testable predictions from them, of like we would expect to see differences between this and this of this magnitude or whatever. And broadly speaking, like our field doesn't tend to do that anyway, but it's even more difficult when it comes to, and that's for simple questions, but it's even more difficult when it comes to something like periodization, where it's very difficult to even nail down what we mean by periodization in that sense. And so one of the things we kind of talk about in the paper in the kind of second half, where we sort of question, is it a myth or is it a theory, is to say, well, Popper kind of always said that like theories come from myths. Myths are this kind of like attempt pre-scientifically to kind of try and explain why things seem to happen the way they are. But he always kind of argued that the idea is that like these myths should over time evolve into more and more kind of precise explanations, such that we can then generate predictions and test them and try to falsify them. And if we come up with a precise prediction, then we can put it undergo what's called a severe test. And if it survives a severe test, which could have falsified it if it was wrong, then we get more confident in the theory, or we falsify it. But like we say, the problem is it's kind of so underspecified and underdefined that it's difficult to know what it predicts in the first place. Like it's difficult to know whether or not the predictions are with relation to managing stress or avoiding overtraining, or whether it's relating to the particular ordering of stimuli and manipulation of training, of programming variables and so on. It's really difficult to know, and therefore really difficult to come up with anything other than generally proponents of periodization say it should do better than not periodizing, but then we fall back to the problem of like, well, it's not clear what you mean by periodization, so we're not sure how to answer that question. But I think also as well, there's other interesting things around periodization, which when you dig into the kind of philosophical and sociological literature around myths in science, there's other bits which kind of like lead me to somewhat antagonistically, but you know, you got to be a bit out there to get attention, to call it a myth, because I knew it would rub people the wrong way. But it was a good example to also talk about you know, the sorts of mythology that can kind of come alongside it. So proponents of periodization would often rely on a lot of kind of I don't want to use anecdotal because that makes that sounds more derogatory than it is.
Like kind of case study.
Yeah, it's case study. It's what we would call kind of like I say, it's inductive inference from we had these successful athletes, and they did periodization, and therefore it must be the periodization that did it. It's a flaw called affirming the consequent in terms of logical fallacies, and one of the problems is you know, and they still do it to this day. They'll comment about like the success of Soviet bloc countries, you know, during the sort of 50s and 60s, and the implementation of periodization approaches during that time. And yet, what they'll do is they'll fail to consider you know, other competing explanations, which could quite as easily be plausible explanations for it as well. So, you know. I mean, one of the arguments that people often make as well is that, well, the US, and this is also a bad argument against periodization. People will say, well, you know, the USSR was doing great in the 50s and 60s because of their extensive, you know, the additional supplementation they were engaging in during that time as well. But the fact is that the US were doing it, everyone was doing it, like at the time. So it's not really the thing that differed between them. There's an even more simple explanation for it, which is purely based on statistics. Which is the USSR had a much bigger population, and they had the most focused sampling process and athlete selection process, and so it purely comes down to kind of like statistical bias, essentially. That like if you have a big enough population, you're more likely to get outliers, and if you're specifically looking for outliers, you're more likely to find outliers. And so in
the socioeconomic background too, where you're trying to like, I mean, we lived in Romania for a few years as well. You know, people you're in poverty. You're literally in sports school from 6 years old or whatever it is. You literally train every day. Your parents get paid for your training, and you go to school a couple hours twice a week. To actual school, and the rest of it is just training. You're a full-time athlete at 6 years old.
Yeah.
Because that's the only way you can make money.
Yeah, exactly. And what I find interesting nowadays as well is I chuckle to myself when people then bring up modern examples of this, because I think there's an interesting paper written by social psychologist Kenneth Gergen back in the 80s, where he talked about one of the problems with psychology as a field and sociology as a field is that their their theories can have feedback loops on the population that they're supposed to explain. So once people start to know about a sociological theory or a psychological theory, and it becomes like part of the zeitgeist, like they can start to change their behaviors to the point that suddenly like the theory no longer like the theory applied only in that period in time before no one knew what the theory was. And so now and I sometimes think that periodization is a little bit like that now, because like everyone, like you probably can't find a single high level athlete that doesn't do something that could get called periodization, because everyone thinks it's the best thing to do, and so everyone does it. And so, but also then you miss out on the fact that also so many like weekend warriors and amateur athletes, and most of them are doing some kind of periodization nowadays. But no one ever points out all the athletes that don't make it. They're also doing the doing the things that apparently are the things responsible for it. But yeah, then you've got other aspects that are similar to that as well. So, you know, there's often a, and again, I definitely don't want to kind of discredit the important role that the coach plays. But it's easy to fall prey to like experience from successful coaches who will say, I did this with my athletes and that's why they were successful, or that they will think that you know, they'll overemphasize the things that they think are responsible for the outcomes that they see. And I'm sure John has written about this, John Carley's written about this as well, where time and time again, if you look over research that has got experts in particular fields to try and predict outcomes, you know, and try and understand what is responsible for the outcomes that they see, they typically don't do very well. They believe their own hype as much as anyone else does, and so there is a sort of it's difficult to. Or I think it's certainly a weak form of evidence to rely on kind of simple heuristics that come from sort of like overconfidence of professional experience in some cases. That's not to say they don't have an incredibly important role, but I think when it comes to saying whether periodization works or not, I take it with a pinch of salt. And then, yeah, you've got other things as well, which have been spoken about in the kind of philosophy and sociology of science with regards to kind of myths in science, is that there is this, there's often a kind of what gets called misborrowing of auxiliary theories. So people were probably familiar with hearing periodization and then it being likened to things like Cellier's general adaptation syndrome, which is the kind of primary theory that was kind of borrowed to kind of provide an underlying kind of biological or scientific plausibility to.
Do you want to maybe quickly explain general adaptation syndrome?
Yeah, well, I mean, essentially, it's just a stress adaptation model. So the idea being that there is kind of, you know, different stresses will. Cellier's theory was, you know, different stresses will eat into this kind of amorphous kind of adaptation energy that we've got, and they will stack and stack and stack until eventually that adaptation energy is used up, and then we no longer adapt to those stresses. Instead, we kind of start to experience negative outcomes from them. And the thing is, like I say, misborrowed, because Cellier's work on developing this theory, which now also we don't necessarily accept as a good explanation for the kind of stress response that we see from these different stimuli, but a lot of his original work was done on very, very extreme applications of noxious stimuli, typically in animal models, or almost exclusively in animal models. And so it's not necessarily even clear that even in the first place, any of his research underpinning what his theory was at the time was even necessarily applicable to, you know, to the models of periodization that were being used. And then you also get, you know, and I don't know whether this is necessarily deliberate or not, and I'm inclined to offer a kind of generous interpretation. So I don't think it is. I think it is that people genuinely just don't necessarily see the flaws in the arguments that they're presenting. But there's good evidence in other fields like neuroscience as well, that people tend to find explanations of things that have more kind of like biological kind of or neuroscientific or, you know, some sort of like sciencey sounding sheen to it, more convincing than if you just provide them with a fairly simple explanation that's actually true. And so people get kind of like lured in by these kind of like very sciencey sounding kind of pseudo-scientific waffle that kind of goes
Mhm.
alongside it. I get very annoyed with it. Well, I say I get very annoyed with it. I'm kind of tired of getting annoyed with it at the moment. With there is a heavy resurgence of kind of the mechanisms folks in strength and conditioning and
Oh
particularly
yeah.
resistance training at the moment. Who again I think are utterly misapplying what could be an interesting Popperian kind of approach to research, which is to say they will take what in the first place are probably questionable assumptions regarding the underlying mechanisms of how things do work anyway, particularly given how unreplicable so many findings in our field probably are, given the small sample sizes, noisy measures, and so on. And that I'm often skeptical as to the extent to which some of these kind of so-called well-known physiological mechanisms are even good assumptions to work with. But what they'll do is they'll start with these this physiological mechanism works this way, and therefore you have to train like this because you'll get this outcome. Instead of taking it and going, well, if things work by this physiological mechanisms, we should get this outcome, and then designing a study to test it with outcome measures. Instead, they don't. Instead, they just take as assumed their initial kind of deductive arguments and then just work with that. So I find the whole mechanism. I'm tempted to write a paper called "Against Mechanism" for sport and exercise scientists, just to highlight how easy it is to get misled by some of the mechanistic research. And again, I'm not saying it's not important. I'm saying that when done well, it's incredibly important and valuable for us to build and generate strong theories to test. But our field just doesn't do that. Our field doesn't. It doesn't take the time to kind of develop strong theories and then come up with good ways of testing them. It likes to.
You can make more money. You can make more money if you run straight to the mechanism.
Well, true, absolutely. Yeah, you can sell books and you can do crappy infographics and all sorts. So yeah. But yeah, so I guess overall, it's interesting. I used periodization as the example, and I've been writing a lot more and working a lot more in kind of broadly speaking the methodological literature lately. And for example, I've written a couple of book chapters lately as well. One which is an introduction to philosophy of science for sport and exercise students for a new research methods textbook that will hopefully be available. Will hopefully be finished by the end of the year. So this chapter was fun because it was my attempt to I'm going to pick a topic that everyone will get annoyed about, and either they'll think, oh, I love the idea of reading about the myth of periodization, or they'll be like who the hell does this guy think he is? And then secretly what they will have done is read a chapter about philosophy of science with periodization as the example.
Perfect. I'm gonna ask you a specific periodization question. I don't know if you have the answer or you did the research in the paper. There's some questions in the chat. I'm gonna basically reword them so it's maybe a little easier to answer. But did you go through any research, or is there any? I mean, you mentioned obviously the periodized research is pretty again wishy-washy to paraphrase, but for example, different types of periodization: block, linear. I mean, undulating, whatever. Is any of those in the research showing potentially slightly superior outcomes for whatever they're testing? Or is it again just like this, it's so small you can't really deduce, what is doing what?
Yeah, so I think certainly for so let's we'll take hypertrophy out as the example, because like I say, I'm unconvinced that there is any research in other than, for example, some recent studies that we've done where we've actually managed to achieve very large samples for randomized controlled trials, and in those we find no difference between any interventions that we look at in terms of hypertrophic outcomes. So I am incredibly skeptical that any of these, assuming that it's just generally a pretty hard, resistance training program, people are training with sufficient effort, it probably makes no difference whatsoever. Or certainly, if there was a real difference, I'd love to do this study because I think it would really upset all the hypertrophy bros, is I'd love to do. I've done some work in psychophysics as well, because another topic of interest of mine is the perception of effort, and so I do a lot of work in psychophysics. And there are study designs which are common in psychophysics to look at what is called the just noticeable difference. So, what is the difference in stimuli that you can actually notice? Like, how big does the difference need to be before you can tell that there is some difference? And I've always wanted to do a study where we use like standardized, like before and after images, and we have either MRI or ultrasound, essentially kind of like measures of muscle size pre and post. So we know, for example, this individual grew by 0.5 centimeter, or 3 centimeters squared, or whatever. So we'll collect a large sample of that data and then conduct a study where we essentially determine what is the just noticeable difference, like visually, for changes in muscle size. And I would probably put down a reasonably strong bet that most of the changes that we see in terms of causal effects on hypertrophy from resistance training interventions in the literature are probably barely, if we're lucky, above the just noticeable difference threshold. And certainly any differences between interventions are probably not even going to be noticeable by the eye. And the reason I say that is because the people who get really animated in the debates about hypertrophy research are the ones who care about aesthetic goals like bodybuilding and figure athletes and stuff like that. And I always laugh and say like, well, why don't you actually like use, instead of measuring it via ultrasound, why don't you actually take standardized pre and post photos and see if people actually look bigger or not? Because that's the thing you care about. But anyway, I digress. That's a separate thing. So certainly for strength, I think this is where, like, what you see in the literature, where you see outcomes for strength that favor a particular periodization modality or like model, or programming model, whatever people are deciding to call it nowadays. I'm going to say programming. So block, undulating, etc. Typically what you see is that however it's set up for strength outcomes, when the group which is training with a load closer to the 1RM, so if they're training with 80, 90, 95% 1RM versus lower relative loads, in closer proximity to the post testing, will typically see greater outcomes. And the simplest explanation for that is it's a practice effect. It's the specificity of training. There is we all know there's a skill element to strength as well, particularly unless you're looking at it in very isolated circumstances like single joint maximal isometric testing. There is a skill element to it, particularly because most of these studies the outcomes they'll look at will be like the big three. So they'll look at like squat, bench, deadlift, because that's what everyone looks at, and we all know they're exercises that have a skill element to them as well. And so the more you practice lifting heavy loads, the better the outcomes will be for them. And so in some sense, like for example, if I talk to people who are looking to maximize strength for a particular point in time, then I'll say to them, yeah, absolutely, program it so that you practice what it is you're going to be going and doing on that stage or whatever, on that platform. So that you can maximize it when you get to that point in time. But I would also say for other outcomes, things like, broadly speaking, kind of other proxies for sports performance, things like power outcomes and stuff like that. Again, principles of specificity typically take over. So if people have been doing training that could be called power training and that better reflects the test closer to the test in terms of time, then they typically get greater outcomes for that. But when it comes to actually broader sports performance as well, and I like to differentiate them between, like, we have studies where we say, like, oh, we measured kind of sports performance outcomes, and it will be like a 10-meter sprint or something like that. And it's like, well,
counter movement jump.
Yeah, counter movement jump or whatever. And it will be like, well, the actual sports performance is like, do you win? Like, that's the thing that people really care about. And that's an even more difficult thing to look at, obviously, and it's also a much more noisy measure, and you will need very large sample sizes to detect it. But this is also where I think that one of the concerns I have is that we can get a little bit too bogged down in trying to focus on optimizing for performance the strength conditioning approaches that we have, when probably the thing that's going to optimize for performance is the more time they get to spend on tactical and technical work as an athlete. And the way I often look at the kind of strength and conditioning components of it is the main role of the strength and conditioning coach is to make sure the athletes are robust and not broken and less likely to break. Because you know what doesn't perform well? A broken athlete. So that's the way I kind of look at it. And God, I thought I was going to get chased with pitchforks at an American College of Sports Medicine conference a few years back because someone asked me a question. And I think I could rather pointedly said I would be skeptical as to whether there would be a noticeable difference in athlete performance if all of a sudden tomorrow all the sports scientists and strength and conditioning coaches disappeared. But
100%.
Yeah,
100%. The strength conditioning is, let's say, quote unquote, important, but athletes can get away with so much, and if you're that good at the sport, it's like, man, yeah, no, I'm with. I mean, as a strength conditioning coach, I agree. Like, you could remove that department from a team, and they can still be successful. Which then begs the question: how much impact is strength conditioning having overall? Now, that's not to say there's no impact, but there's just so many other variables at play that, it's. Is going from this program to that program, is that showing, as you mentioned, that much difference overall? When if you remove the department, maybe they can still win. There's just so much going on.
The mad thing I find as well is that in situations where this stuff where the very small effects could actually be important, and the way I say could actually be important is particularly in sports where there's actually money involved, like if you win makes a difference, there's incentive to actually put the resources and investment in to find out what really is having these small effects. And yet this is something I just find surprising, is that like the world of elite sport, particularly in sports where there is actually a lot of money, very rarely is there actually good science going on with regards to testing intervention effects and things like that. And because the reality is, like, they should know that these effects are going to be necessarily incredibly small in the first place, and so it's going to take a lot of data to figure it out. And yet they've got millions and millions and millions of pounds of money or whatever, particularly if you're looking at something like Premier League football or whatever, and yet they don't put the investments into being able to answer these questions. There's a little part of me that thinks also a lot of elite sports do a lot of things, like they'll have a sports scientist, they'll have strength and conditioning coaches and things like that, because that's what everyone should be seen to have nowadays. Like, you would
have GPS just to look like they have GPS.
Exactly. Yeah. Whether or not it actually provides anything meaningful or not. And that's the thing. Like, it could all be used for some to answer some very interesting questions. But I don't know. It's sports a funny old world.
Oh, tell me about it. Being through the rigmarole there. I'm just reading a couple of questions there saying that's a great viewpoint for S&C. I'm assuming about what we talked about there not being, the main driver. It's not the majority focus, but the supplemental focus that helps the athlete produce the small but physically more / strong enough to not break through stress and performance. Yeah, pretty much. I actually wanted to go into, you mentioned about the perception of fatigue. I saw your paper when I was scrolling through your research, Gay, and I was like, oh, that looks interesting. Are we talking about perceptions of capacity, fatigue, and psychophysics? Are we talking about potentially what could, I'm not going to say cause, I'm just going to say cause because that's all I can think of right now. What could cause fatigue during exercise?
So
is that what you're kind of looking at?
Yeah, sort of. So one of the things I look at is, and again, this is kind of probably my philosophical side. I spent a long time working on the topic of effort and fatigue, again, because they're two poorly defined concepts and we're not the only fields that work on these. There are, I've done a lot of cross-disciplinary work around these areas, working on areas of cognitive effort and fatigue as well. But I published a paper a few years back providing what I think are kind of like good definitions for effort and fatigue. And fatigue is essentially something that I look at as being, and effort, and this is where it lends to the psychophysics element is, from a psychophysics paradigm, we have, as a human, you have experience, feel things, you perceive things and stuff like that. And you know, we're sat here talking to each other nowadays, but like, you don't really know if I'm a robot or a zombie. You assume I'm having similar experiences to
You're
yourself.
definitely AI.
Yeah. But the idea being that within the psychophysics kind of paradigm is we have like actual stimuli, so like how bright the light is, and then how bright you perceive it to be. And so we can think of effort and fatigue, or our perceived capacity, to be the same as that. Like, there is some underlying actual effort required for when you do a given task, and then there is how effortful you perceive it to be. And the same with fatigue as well. But one of the things that we did with that paper was it started off from my work with effort, because I view effort as essentially being this relationship between the demands for a particular task that you're trying to perform. So to keep it simple, let's stick with lifting weights. Like, you know, the demands that lifting a particular weight poses on you, relative to your capacity to meet those demands at any given point in time. So, you know, nice simple example is if you've got a 1RM of 100 kilos and you lift 50 kilos, well, that represents 50% of your 1RM, and assuming no fatigue, anything else, like it requires 50% effort to do it. Now, whether it feels like 50% effort or not to you is the thing that may or may not differ. But in the one of the things that we looked at in that paper as well is I talked about it in the context of capacity. So you can think of your perception of effort as being, well, how much capacity do I perceive like I have, and how demanding do I perceive this to be? And then there's this kind of potentially this metacognitive process that goes on in your brain where you kind of like relate those two to one another. But you could also think about your perception of capacity in relation to your perception of fatigue. So like, if you imagine, like, if I am at full capacity, fully rested, but then I go do some, you know, I do a set of reps to failure, I could think to myself afterwards, well, I perceive myself as being fatigued, but what that fatigue is I perceive my capacity as having been reduced. Like, if you ask me to do a 1RM immediately after finishing a set to failure, like, I already feel like it's not going to be as heavy as it would when I'm fresh. And so in that paper, we looked at basically this idea that the literature that looks at perceptions of capacity and the literature that looks at perceptions of fatigue are basically looking at the same thing, but just reversed. So if you say, I feel like I feel like my fatigue is going up, well, what you're saying is your capacity is going down. And that was a paper where it was interesting because my colleague Jim Nuzzo was working for an organization at the time where they were collecting data, and he wanted to include some of these outcomes in there. So I said it would be a good opportunity to test this idea, because if you collect both, we can then look at the relationships between the two. Because if people are, if those two things, how your perception of fatigue and your perception of capacity are basically the same construct, like psychologically, but they're just going in different directions, we should see like a really strong negative relation between them. And we basically found that it was. So like when perceptions of fatigue are essentially just your brain's kind of evaluation of how much capacity you think you've got left. Relative to kind of like your freshness. But one of the things we also looked at in that as well was because, going back to this idea of actual versus perceived capacity, or actual versus perceived fatigue, or actual versus perceived effort, is we also engaged in some fatiguing protocols where we were able to then measure forces throughout them as well. So we had like fresh like force, which would be like the equivalent of, say, like a 1 rep max. So what's your MVC when you're completely rested and whatnot? And then we could see how much actual capacity people had lost throughout the task. So we were able to then look to see like how accurate were people's perceptions of their capacity loss relative to their like actual capacity loss. And we see what we similarly see with like things like perception of effort, and what we see with things like you know, people often use like people use the reps and reserve model a lot as a kind of proxy of perception of effort. You know, obviously the closer to failure you get, the more effortful it gets. But we see across all of these literature that people are not completely accurate in their perceptions here. Like on average they might be, but in any given situation they're not going to be spot on what it is. And so it just allows coaches to think a little bit more about like, okay, do people typically underestimate? Do they typically overestimate what they're doing here? And how do I then use that to kind of like apply, you know, training principles with our athletes? So that paper specifically, it was probably more of a kind of like theory testing paper because we had this theory of the two. But some of our other work on this area, looking, like I say, at proximity to failure and ability to predict, or accuracy in predicting proximity to failure, we did a meta-analysis with Israel Halperin a few years back, pooling all of these studies, and on average, people underpredict their proximity to failure by overpredict their proximity to failure by about 1 rep. So when they think they've got 1 rep left, they're probably more like 2 reps left. And so it's stuff like that that can give you a little bit of clues as a coach to say, like, well, if I want you to stop at this proximity to failure, I'm going to tell you this proximity to failure because I know that you'll be off a little bit. And also things like, people are worse at predicting how close to failure they are when they're using lighter loads, because typically lighter loads with higher reps typically induce greater feelings of discomfort, and people then start to confuse the two. So if things feel uncomfortable, they kind of misinterpret that as being more effortful, and so they'll underestimate or overestimate more how close to failure they think they are.
Interesting. I'll have to go through some of that paper too. And just to round out the podcast, there's one more I wanted to touch on. You posted on your story how you're rerunning some protein dose response data. I think this will be interesting for the listeners as well around protein intake, because probably still one of the more popular topics within strength conditioning, nutrition, and athletes is, how much protein do we need to take? I'm assuming it's to maximize muscle protein synthesis, what you're looking at there. Or muscle growth or whatever it is across a long-term time frame. Yeah,
so we'll be this is actually we're going to be collaborating with Everson Nunez and Stu Phillips and folks from their lab. So Everson led a meta-analysis a few years back, published in 2022, which is our kind of like most up-to-date meta-analysis looking at the dose response effects of protein intake and lean mass or muscle mass outcomes. They also looked at strength and kind of more functional outcomes for sort of older populations as well. So what we're going to be doing is updating that. So from the point where they cut their searches last time, we're going to be looking over the last few years, adding any new studies to that data set, and then redoing all of the analysis. Like meta-analysis is something meta-analyses are something that I work on quite a lot. And so we're going to be, one of the problems with previous studies, and this is the interesting thing I've had over the last couple of days, because I'm going to go back to the how small effects on muscle really are, is that previous studies that have looked to try and determine the dose response have done not a great job of doing what we call dose response modeling. So they'll either apply a very fixed model where they'll choose, like, for example, in the old Morton 2017 meta-analysis, they picked a particular breakpoint by sort of eyeballing the data, and then fit a kind of plateau model to that, rather than like estimating where the plateau might be, or using like more flexible kind of modeling functions which can allow for kind of non-linear effects to emerge in the data. So one of the things that I've been doing over the last couple of days as we prepare the sort of pre-registered analysis plan for this is using the data from Everson's previous analysis, is rerunning that, but also looking at a bunch of different candidate models for dose response. So seeing like in terms of grams per kilogram per day, what is the effect with changing intake of protein. I should say most of these studies are during whilst resistance training as well. There's only a couple of studies that don't have resistance training elements to them. Is seeing like, okay, is there like a linear response where as you increase protein intake, your increases in lean muscle mass or muscle size increase linearly, or is it kind of like a plateau function, or is it kind of some kind of like smooth other smooth function? And one of the things that we're doing is we're going to propose fitting all these different candidate models and then using certain statistical criteria to determine, of all the models we fit, which is the best explanation of the data, which also takes into account things like parsimony. So it weighs up how much of the variance across the studies is explained, but also how complex is the model, because you can make the models, the most complex model is the one where you just draw where you do a dot to dot between all of the points. But interestingly, at the moment, some very, very simple models are looking like they're going to be the most simple candidates for them. And at least in the old data set from 2022, I can say pretty much now, like the effects of protein are incredibly small, over and above like pretty much the RDA. So any gains that you're getting from shifting from just in sort of RDA level intake above that are tiny little. Oh, I've lost your audio there.
Oh, sorry. The RDA is is it 0.8 grams?
It's 0.75. In some places it's 0.75. Some places it's 0.8.
Okay.
Yeah.
Grams per kg of body weight, right?
Yes.
That's
Yeah. And so what we see is like you fit the model and so as I said earlier, a standardized mean effect of about 0.34 is roughly the effect that you see from just people who are resistance training anyway. And most people in resistance training studies are probably somewhere around the RDA, anything. If those studies aren't designed to kind of try and maximize protein intake, maybe a little bit more. And what we see is the estimated effect in the current data set around the kind of RDA. It's pretty much around that effect size estimate anyway. And any increases that we're seeing with increasing protein intake are relative to that really small. So you're looking at sort of like going from like 0.8 to like 1.8 grams per kilogram of protein. So like a 1 gram increase in protein. You're moving from something like based on the figures I've looked at this morning, you're maybe getting like an extra like 0.05, 0.06 standardized mean effect out of it. So yeah, there's maybe a small increase, but it's a very, like, again, I go back to the point where it's like I'm not even sure that would be noticeable to anyone.
Yeah. For the non-statistic geeks like myself, that's 0.3 standard deviations.
Yes. Yeah. So that about 0.34 standard deviations is basically the effect of resistance training versus not resistance training in untrained people. And when you're looking at trained people,
that doesn't change much with increasing protein.
Not much.
Okay.
Like you might get it up to maybe 0.4. So it's not a huge effect. But also we have very little data above that. And if I were a betting man again, I would probably bet that if we have more studies with high protein intakes, we'd probably start to actually see that there really is like not a huge dose response effect from it. But I'm always the as Eric and the Ericses and my student Zach keep on calling me, I'm the black pill guy. So I seem to have got a reputation now for just dashing all the bros' dreams.
Oh, that's funny. Yeah, I mean that's all over social media, as you probably know. You know how important protein intake is when resistance training is probably trumps everything else. How hard you're training versus how, I guess, the small changes you can make in terms of protein and dietary intake, which is quite funny because obviously, people talk about everything is 80% diet and 20% training is kind of like the general heuristic that's thrown around. When you look at it, it's kind of like, well, you can look at some of the top pro level athletes and you see how they train. I mean, yeah, they are genetic freaks and they're great at the sport, but some of them they only eat candy all day.
Yeah. I think I'd probably look at it as well. Like it's like if weight loss is the thing you're interested in, then diet's the important thing. If muscle mass gain is the thing you're interested in, then lifting weights is the thing that's important. And diet is basically if you're not eating, if you're eating reasonably around the RDA, then you're probably getting 95% of what you're going to get out of it.
Interesting. Now, pivot that I had one more for you, but I'll cut it there because it's over an hour now. But where can people find and follow you, James, and keep up with what you're doing?
Yeah, sure. So as you mentioned, like I'm on ResearchGate, so if people want to see my actual research outputs, I tend to keep that pretty up to date. So anything new will go straight up onto there. I am on Instagram. I'm not as active as most social media people. It'll either be pictures of my cat or it'll be like snide kind of like memes, like taking the mick out of bad research. So I'm on Instagram. It's james.steele. I think it's, actually, I can't remember my own handle now.
I'll post it down the bottom anyway. When this is up.
It's basically James Steele the second, James Steele II, because my dad's called James Steele as well. So it's always been a bit of thing. Like I'm James Steele the second. Yeah, and I mean, I'm not on Twitter anymore, but I'm over on Blue Sky a little bit with the same handle. So yeah, people can find me on there.
Perfect. Yeah, I found it. James.SteeleII. Perfect. I'll link that up down in the description anyway. But I appreciate you coming on and sharing everything, James. That was awesome.
Yeah, no worries. Thanks for having me.